Hi, in this video we are going to discuss the Kirchhoff's voltage law or Kirchhoff's loop law. So as you can see in this picture, we have three resistors connected to a voltage source. So the Kirchhoff's voltage law states that the total voltage within a loop, like the one we have here, should be zero. So the summation of the source voltage and all the load voltages must be equal to 0. So if I mark V1 as the voltage across R1 and V2 across R2 and then V3 across R3, and I consider the source voltage as well, the KVL equation would be V plus V1 plus V2 plus V3 should be 0. So in order to understand and apply KVL, we need to understand the concept behind assigning signs to the voltages. So over here I've got a resistor, and for any resistor, whenever a resistor appears in a circuit, we're going to mark its voltage as a negative voltage, because when charges pass through that resistor, they dissipate their energy and therefore they lose their potential drops, and therefore we will mark it as a negative voltage. In case of a battery, if a current is traveling from the positive potential, that is the high potential, to the low potential or the negative potential, it means charges have lost some potential and there is a voltage drop in the charges. Therefore, we would put a negative V sign for this kind of battery as well. However, if we reverse the condition, that is the current flows from the negative potential to the positive potential, it means that the charges are traveling from low potential to high potential, therefore they're gaining voltage and there's a voltage increment, therefore we will be marking it as a positive V. So the overview is that for any resistor, you're going to mark it as a negative V, and for batteries, you're going to see the flow of current. So if the current is flowing from positive to negative, there would be a voltage drop, and if it's traveling from negative to positive, there would be a voltage increment. In order to understand KVL better, here's an example circuit. So in this circuit, we've got a source voltage of 10 volts and then three resistors of 5 ohms, 2 ohms, and 7 ohms. And we're going to assume a current I, and this is a random direction. So first of all, I'm going to mark the resistors as R1, R2, and R3. Then I'm going to write the KVL equation. That is, the sum of all the voltages in this loop must be 0. So I've got the source voltage, V, and over here I'm assigning a positive sign to this voltage because the current is flowing from negative to positive. And then I'm going to put V1, V2, and V3 with a negative sign because these are the voltages across resistors. And so this sum should be equal to 0 according to KVL. So I'm going to use Ohm's law over here, that is V is equals to IR. And we're going to put the values in this equation. So the source voltage is 10 volts. And in place of V1, I'm going to write 5I. So I over here is actually the loop current that we assumed. V2 would be 2I and V3 would be 7I. If you solve this equation to find out the value of current, you will get I is equals to 10 over 14, which is 0.71 amperes. So I'm going to write this value over here so that I can rub the board and solve for V1, V2, and V3. Now we can find the values for the resistor voltages. So using Ohm's law, I'm writing V1 is equals to 0.71, which is the value of I, multiplied by R1, which is 5 ohms, and this would be equal to 3.55 volts. Similarly, V2 would be 0.71 multiplied by 2 ohms. That would be 1.42 volts. And then V3 would be 0.71 multiplied by 7 ohms, and that would be 4.97 volts. And so in order to check and verify our solution, we're going to add up all of these voltages and see if they add up to become equal to the source voltage, because according to KVL, we had written this equation: V minus V1 minus V2 minus V3 should be 0, and if you rearrange it, it basically transforms into the source voltage must be equal to the summation of all the individual voltages across the resistors, that is V1 plus V2 plus V3. And so if you put the values of these voltages over here, got 3.55 plus 1.42 plus 4.97, and I add them up, it comes out to be 9.94 volts. It should have been equal to 10 volts, but it's not, because we approximated I as 0.71. If I had taken 3 decimal places, this would have been a more accurate result. So it's a minor approximation error. Another practice problem for you guys: you can hit the pause button here, solve to find out the voltages across these resistors, and then resume this video to see its solution. I'm marking the current I over here. This is just an assumed direction. So in order to find out the values of the voltages, I'm going to mark them as V1 and V2, and then I'm going to write the KVL equation. So for this loop, I can see that the current flows from negative to positive in the 4-volt source battery. So I can write it with a positive sign, and then the resistor 2 ohms would have 2I current. I'm using Ohm's law directly with a negative sign because this is a resistor. And then the 5-volt battery would also have a negative voltage because the current in this battery is flowing from negative to positive. And then the voltage across 3 ohms resistor is written as minus 3I. If you solve it for I, you would get minus 1 minus 5I equals 0. And so I would become minus 1 over 5, which is equals to minus 0.2 amperes. So this negative sign just tells me that the assumed direction of the current should be reversed. Right, so I'm going to reverse it over here and write the value of I down here so that I can rub the board and find the voltages across the resistors. So again, I'm going to use Ohm's law. So V1 would be equal to 0.2 multiplied by 2 ohms, which is equals to 0.4 volts. And then V2 would be equal to 0.2 multiplied by 3, which is equals to 0.6 volts. And our KVL equation was 4 minus V1 minus 5 minus V2 is equals to 0. And I'm going to put the values of V1 and V2 in this equation. So this would be then 4 minus 0.4 minus 5 minus 0.6 volts. And this actually does come out to be 0. So I know my solution is correct. So I hope you found this video helpful and informative, and hopefully your concept about KVL is now clear and you can use it for your future circuit analysis. And if you enjoyed this video, if you found it helpful and informative, please share it with your friends and family and subscribe to our channel. See you in the next video.